Nanotechnology, the presentation by Dominic, Toby and Ollie Norton.
Nanotechnology is the manipulation of matter on both an atomic and a molecular scale. It focuses upon distances at an extremely small scale.
1 nanometer is equal to 1 billionth of a meter. That's 1 times 10 to the minus 9. Thus, at this level, the surface area is massively increased, causing the materials to behave in a new and interesting way.
And because of this, and the many properties which we have yet to discover at this level, we are therefore considering it a valid piece of science. The part we're going to be discussing is called setae. The setae are something found on geckos' feet. This has been only recently discovered, and it is found due to the gecko's ability to climb on walls without any form of adhesive, which has perplexed scientists for absolutely ages.
It's formed by the fact that the small setae increase the surface area on the gecko's feet, and therefore the setae are basically stiff bristles that then expand the surface area on the gecko's feet and help.
Each of the setae branch off into even smaller projections called spatula. They're called spatulae due to their shape, which mimics a kitchen spatula.
Therefore increasing the surface area on the gecko's feet even further.
Synthetic setae is mankind's attempt to recreate this. Unfortunately, we are yet to actually have anything on quite the same scale as the gecko, and thus it is nowhere near as currently effective.
On the gecko's foot, there are 14,400 setae per square millimetre, whilst most modern setae so far have fewer in perhaps a tenth of this number,
Because our research and understanding of nanotechnology has increased in the past couple of years, we've started to be able to produce synthetic setae, be able to produce things small enough to replicate synthetic setae, which can be applied to things like gloves or suits, which rely on humans to stick to walls.
The abilities of synthetic setae are mildly varied. One of its main uses, which are quite interesting, is its own self-cleaning ability.
But first of all, to be able to stick to a wall, there's got to be some sort of force, and the force is called Van der Waals force, and that's literally just a simple attraction between two substances. It's usually a weak force. However, due to the increased surface area caused by the spatulae and the setae bristles, this force is greatly increased to be able to hold the gecko's weight whilst upside down on the ceiling or climbing vertically on the wall.
This effect is shown by the diagram on the right of the presentation.
The self-cleaning ability of the setae is due to the fact that it becomes cleaner with everyday use. As the setae attempt to stick to a wall, and a large particle is more attracted to the wall due to the Van der Waals forces. Therefore, every time a particle sticks to the spatula, it is actually removed upon being placed upon another surface.
This means, because it cleans itself, it means that if we use synthetic setae as adhesives, they won't wear out or lose their stickiness from and things clogging the surface of the adhesive.
And breaking the bonds between the two things being stuck together. Some commercial uses are high grip ties and a thing called a spider lancing, which is yet to be fully developed, but it's possible.
It's a concept based upon the gecko's ability and thus would allow a human to scale any plane surface. There are uses in current football gloves of a slightly lower quality to have such a high level of grip.
That's it.